I think I've completed 4-1 in class.
It's like connecting. Is this an on or off thing? Like graphs, like an open circle and a closed circle, and
Is this in your pie?
no, it wasn't a homework. I know it's like that was what we were doing last time, wasn't it?
Now, there's difference between 1-to-1 and a function. Is it asking if it's 1-to-1? 4.1 would have been asking 1-to-1. Yeah, so 1-to-1 would pass the horizontal line test. So x squared is not a 1-to-1 function.
So, but that's part of the homework in
4-1.
Okay.
Because that is all beginning to find the inverse function. The inverse function does not exist unless the original function is 1-to-1.
But it's going to have graphs that show the connection, like the circle. I mean, it just looks like stuff from.
Yeah, like if I give you a circle, is this, does the inverse exist? No.
That's not what was
First off, or just dots. Or,
Yeah.
I mean, yeah.
Yeah.
I did this one in class. I did the whole 1.1 in class. You know, if it was something like, I don't know, or just dots.
Yeah.
A 1-to-1 function will pass the horizontal line test. So if here, these are all fine except for this part. That's not 1-to-1 because it fails the horizontal line test. It is a function because it passes the vertical line test. So two things have to happen for the inverse to exist. You might have some classification on the test. Is it a 1-to-1 function? You know, here's a couple of examples. X squared, if I say inverse does not exist here, unless I say x is greater than 0. Then the inverse would exist, and it would be the square root of x, right? Because it's kind of, the inverse undoes what the function does. So this is a simple example. But yeah, here you're just classifying is it 1-to-1 or not. A function will be 1-to-1. It will pass the horizontal line test. That all leads up to if it is 1-to-1, an inverse exists. So you can be able to find the inverse. More important is being able to find the inverse in that section. And we did some take-home quizzes and some quizzes in class finding that and some lectures. So there definitely will be one on the test that says find the inverse and on the final. So you want to be comfortable doing that. Any other questions? I think we've done 4-1, 4-2, 4-3, and 4-4 on Alex in class. So if you go back and watch those lectures, I go through all the Alex problems and submit it and look at the grade.
I need help with
Okay, so for the log or?
it's the E. It
Okay.
looks like it goes in right.
Mm-hmm. 0.0. So what you
And
have to
then I
hit,
do that,
Mhm.
but do it.
parentheses.
It keeps saying error.
Okay, you have a Y though. You don't want Y.
You
You want,
Watch it.
go back here, E. Let's just,
I can't find error.
so what is this? 2200.
I can't. Well, I can be back here on Wednesday.
What is this? Like, this is X.
I just want to hear what you have to say about it seriously. No, it's hilarious. Okay, well, you can't say it without in like 15 minutes.
2.
Oh, okay, we'll just see that. I didn't know that. So you should.
Well, I just.
Okay, so I didn't know that. No, that's cool.
I don't see it, but it should have a carrot.
That's fine. Because my mom gave me the location. I would never focus on her. Yeah.
That's why I
Yeah.
use that
Either love or
carrot.
hate it. I totally understand. That's cool.
I push this.
Not usually. It's just in this, he's just so over the top, annoying, like in your face. That's what I think is funny. But other than that, like. He's just so obnoxious.
I can't use my tablet on the tester.
No.
I don't know, I just have my bias.
Yeah, I don't see it
No, I
here.
understand. Well, now I really want to.
I can look it up on your class if I can find
Okay,
the way you
I
put it in.
did.
Because I've never used it
It is
like
it's-
this.
Well,
Not to say it doesn't have it, I don't see the button right off.
Well, I mean, like, he's like.
Yeah, it's,
like,
see,
like,
let me see what it is, X, Y.
Nobody cares. I mean, it's just, I know. And then like, it's frustrating.
It works for the other problems with that sheet, that's why I just didn't.
Yeah.
And it comes out with the right answer.
Yeah, I'll play around with it after class. Oops, so sorry. Does anyone need the lecture notes from 4-5? We're gonna finish that today. We're halfway through it.
It's 4 to 5, right?
4-5. Okay, so last time, 4.5 really just combines everything from 4.1 to 4.4 together and solving for x. Right? So we first looked at some exponential equations, and we had two approaches. The first approach, we said if they have the same bases, right? We use this, if b to the x equals b to the y, we can set x equal to y. So the first two examples, we were able to identify 81 as 3 to the 4th power. However, if you didn't identify that, you could take log base 3 of both sides and plug it in your calculator, log of 81 divided by log of 3, and get 4, right? So at that point, it becomes a 050 problem, really to solve for x. Right, do you guys remember doing that? I remember it's been a long weekend, so the first 4 we did, it turned out we could manipulate all the bases to be the same base. That's not always going to happen. And the next page, we looked at some where the bases were not the same. Like this one here, we have base 4 on one side and base 5 on the other side. There's no way to manipulate that to get the same base. So I can either take log or natural log of both sides, use properties of logs that we learned in 4.2 or 4.3, and come out with a 050 problem. The only thing different is we have this ln of 4. ln of 4 is just a number. ln of 5 is just a number. So if I want to solve for x, I got to get the terms that only have an x in them on one side, everything else on the other, pull out the x, and divide through by that number. And we talked about how we could write these things differently, right? I could write 7 ln of 4 as ln of 4 to the 7th power. There's infinite number of ways to write this, and that's why I want to see you plug it in your calculator and get a decimal approximation, so then I can confirm that is the correct answer. I'll look at both.
How can you pull out an X?
Mm-hmm.
You can't pull out like an LN.
You could, however, I don't care. I don't want to solve for ln of 5. It's just a number. I could, but then I have to divide through it. You mean like pull out the ln here, then have 4 minus 5?
Yeah.
No, because ln of 5 is the number. It's not ln times 4. And the last one we talked about was the U substitution method. So if you have something like e to the 2x and e to the x in the same problem, you can't isolate that to one side. So you have to use the method of the e substitution. Now I left part B on both of these. Did you guys have a chance to work those out? All right, so I think it'd be kind of a good refresher to work them out now. So let's first look at this B. This 3 to the 5x minus 6 equals 2 to the 4x plus 1. We're looking for the x value that makes the left-hand side equal to the right-hand side. So what's my first approach here? Yeah, all right, I want to get rid of my exponents. To get rid of exponents, I can use log or natural log, and that will allow me to take my exponents as coefficients. right? So let's see. We didn't do it in class. I asked you guys to do it, but so you follow directions. But yeah, I didn't confirm the answer here. So if I was to take ln, I use ln because it's one less than log. It's just a little shorter. You can use log though. It will give you the exact same answer. So ln of 2, 4x plus 1. Yeah, so the whole purpose of doing that is to take my exponents and I move them down as coefficients. Right? So then I have, go ahead and write, this is 5. This is 5x minus 6 times ln of 3 equals 4x plus 1 times ln of 2. You want to be very careful when you do this to put parentheses around your exponents because you really need to distribute that ln of 3 and ln of 2 to both terms. So that's a common mistake students make is they don't distribute the ln of 3 or the ln of 2. So my next step is to distribute it, get rid of the parentheses. If I do that, I have 5x times ln of 3 minus 6 times ln of 3 equals 4x ln of 2 plus ln of 2. Looks a little uglier than 050 approaches, but they're just numbers. Right? And I can wait until the very end to plug it in my calculator and just leave it as ln of 3 and ln of 2. Yeah, so I want to isolate my x. I have an x on the left-hand side and an x on the right-hand side. And I want to move it all to one side. I don't know if it's out of habit. I always go to the left with my x's. Doesn't matter. If you go to the right, answer. But here I have 5x ln of 3. I want this over to the left-hand side, so I subtract it from both sides. Right? Equals ln of 2, because it's already on the right-hand side. And I want this on the right-hand side, so I add it to both sides. You guys see that step? Yeah, so this setup, I'm almost done. I pull the x out of the two terms on the left-hand side. So I have an x. I'm left with 5 ln of 3 minus 4 ln of 2 equals ln of 2 plus 6 ln of 3. Yep. The last step is to get x solely by itself. And my solution at this point doesn't look like a solution because it's a jumble, but it is still a solution. It's actually called an exact solution, but I can't really tell what this number is, right? So I could plug into my calculator. What would I get? Didn't bother plugging in, and that's fine. 2.6777. That way, that number gives me an approximation to plug back into my original expression and show the left-hand side equals the right-hand side. Now remember, if you plug this in your calculator, to be very careful with the numerator and the denominator, because that's been an issue before. Order of operations. Plug the numerator in, put parentheses, divided by the denominator in parentheses. So we're getting a little more comfortable with our calculators. Yeah, I mean, when in doubt, parentheses are your friend. Because some calculators will throw a parenthesis when you hit ln. Others won't. Yeah, so just be aware of that because you want to close that parenthesis. So this will give you full credit on the exam. This just gives you a way to plug that back in to show the left-hand side equals the right-hand side. It gives you an idea, 2.6 too, that's a number. ln of 2 plus 6 ln of 3 divided by 5 ln of 3 minus 4 ln of 2 is a number as well. We just have a hard time relating what that number is. So do you guys understand the process of this? Going over that process, looking at any of the ones we did above, let's go reevaluate part A that we manipulated 81 to be 3 to the power of 4. And we can use the same technique. Say I have 2x minus 6 equals 81. Let's say I didn't first identify 81 as a power of 3. But I can use the same technique, take natural log of both sides, and I would take this, right? Then I would have 2x minus 6 times ln of 3 equals ln of 81. Then I have 2x times ln of 3 minus 6 ln of 3 equals ln of 81. So if I add 6 ln of 3 to both sides, and if I want to pull out the x, I'd be left with 2 ln of 3. Right. So this looks a little more jumbled than our first technique, but plug in your calculator ln of 81 plus 6 ln of 3 divided by 2 ln of 3. And be careful with order of operations, things like that. Parentheses, 5. And that's the same answer we got the other method, right? It looks a lot more complicated, but it allows you to be able to not identify the powers of 3, right? If you didn't know 81 was 3 to the 4th power, you can still solve this problem. If you identify it, the algebra becomes a little nicer, but you don't have to rely on that. It's kind of nice idea to have that you can hit it hard enough with a hammer and get the solution. If you know the fancy tool to use, it's going to take you maybe 2 minutes faster, but it's still nice to know you can use a hammer and get the job done. So you guys see how that works? Not too exciting, but gets us there. Did you guys work at B?
I still do y,
Mm-hmm.
2x would equal, like, u,
Mm-hmm.
2x would equal u squared.
That's a technique. So this is really a quadratic, but our variable is not x, it's e to the x, right? So if I were to say let u equal e to the x, then u squared would be e to the x squared. And if you remember properties of exponents, e to the x squared is e to the 2x, right? If I have a to the b to the c power, I could write that as a to the c times b. Or if you're OCD, then you could write that as a to the b times c, right? So that's just,
So u always equals e to the x.
yeah.
Basically.
So now you can solve a quadratic with the variable being u, which is something you guys have seen in Math 050 or Math 110, right? You're more comfortable solving something that's u squared minus 5u minus 14 equals u than you are solving something like this. But it's the exact same approach. Our variable is not one variable, our variable is e to the x. So our answers are going to be ln of a number, right? Just one extra step, instead of saying our variable's x, it's e to the x. Right? So how would I solve this quadratic? I can factor. What are my factors going to be? So plus 7 and minus 2, or minus 7 plus 2? Minus 7 plus 2, right? Yeah, so then I can kind of check myself, and I could FOIL it and see it's u squared minus 5u minus 14. So u would be 7, or u would be minus 2, right? It could be both, but in this case, it's only one. It's only 7 because it cannot be negative, because e to the x can never be negative, right? So the last step here, and probably this is the step students forget, is we're not solving for u, we're solving for e to the x. So the last step here would be e to the x equals 7, e to the x equals minus 2. So how would I get x by itself? ln of both sides, right? So I'd get x equals ln of 7, or x would equal ln of minus 2. And if you plug ln of minus 2 in your calculator, it says error. The reason why it says error is because you can never take a negative ln of a negative number, right? So our only answer here is ln of 7. You could 1.945910. Yeah, yeah, you would get full credit either way. What's nice about this, you can plug it back in. E to the 2 times that number minus 5, e to that number minus 14 equals 0, and it should equal 0. So the decimal approximations just give you a way to check your work. You could do it with ln of 7 as well.
Do you always have to put the parentheses like in the answer?
You don't. You could put ln of 7. ln of
I
7.
mean, it's better to get a habit of sure.
Yeah, this just tells me you're taking ln of 7. I probably use it most of the time, just like if I had something like this, log base 10. If I drop the parentheses, I don't know what is in the parentheses and what's not. But if it's something that is as clear as ln of 7, there's no really worrying about what's going on there. Those are good questions. So that kind of completes our methods for exponential functions. An exponential function is a base to a power, and the power usually has the variable in it. The next kind of functions we're going to look at is, or equations we're going to look at, is logarithmic equations. And it's going to be kind of the same setup, but what's the inverse of the log? And well, the inverse of ln or log. An exponent, an exponent, right? Just like what we were doing here, to get rid of the base, the exponent, we would take the log. So now when we have a log, what do you expect we're going to do? Put it in an exponent, right? The first two are set up that our bases are the same. So if I was to take 2 to this power and 2 to this power, it's going to cancel, and I'm going to be left with 3x minus 4 equals x plus 2. Right? Now I just solve for x, which is Math 110 or 050. Right? So I subtract x from both sides, add 4 to both sides. I'm left with 2x equals 6. So x would be 3. Now there's a little bit of checking here. You want to make sure your solution exists. Can I plug 3 in here and 3 in here and it not be negative? I can. So a solution exists. It might be where the only solution, it doesn't exist because they're negative. Right? And that's something you'll want to do on step 5. You have to do with logarithmic equations if you want to check the possibility in the original equation, because you can't take natural log of a negative number. Exponents, you don't have to worry about that because the domain is all real numbers. You can plug anything into an exponent. But you can only plug positive numbers into a logarithmic expression. The second one, straightforward. We can use the fact that they're both base 2. And we get 7x minus 4 equals 2x plus 1. Subtract 2x from both sides, add 4 to both sides. We get 5x equals 5, x equals 1. And that works both expressions. So x is 1. So the left-hand side equals the right-hand side when x is 1.
And that's any problem
In this specific
in
problem.
this specific.
So it's almost kind of the most boringest case when you have the same bases, right? You're not always going to have the same base, and you're not always going to have one logarithmic expression equals another. You might have more than one. So what you need to do is combine them to one. So you guys remember properties of logs? So that's what we're doing a little bit further on. So let's just look at some of these. Your book gives you kind of steps. You don't have to memorize these steps. They should make sense. The first thing you want to do is you want to isolate the log. You want no coefficients in front. You want to get it log base b by itself. You want to get it into one expression. So if you have log base b of 5 plus log base b of 3, you want to combine that to log base b of 5 times 3. So you have one expression for log. So how would I get log by itself or no coefficients in front of log on this example? I could do that. I could move it up as an exponent, but I really kind of want to avoid exponents. I could just divide by 4, right? Right? Because having an exponent, then I'm going to have to take the log to get rid of the exponent. It's going to be a vicious cycle. So I want to first divide both sides by 4. So that gives me log base 3 of 2t minus 7 equals 2. Now, what do I need to do to get rid of log base 3? Yeah, I use the log base 3 of 2t minus 7 as the exponent for base of 3, right? So this would be 3 to this power. If I do that to the left-hand side, I have to do it to the right-hand side. So then this becomes 3 squared. The whole purpose of doing that is to get rid of log base 3. I'm left with what's in parentheses, 2t minus 7 equals 9, which is 3 squared. If I would have moved it up to an exponent, I would have had 2t minus 7 to the 4th power equals 3 to the 8th, which is possible to do, but I'm going to have to FOIL this. I'm going to take it to the 4th power. It's going to get ugly. I'll have t to the 4th to solve for. Here I just have t to the 1st power. So you're always better out dividing through the coefficients than pulling them back to powers. You want to avoid that. Mathematically, you haven't done anything illegal. It just has made your problem a lot harder to solve for. Now this is just solving for t. Add 7 to both sides. 2t equals 16. Divide both sides by 2. T equals 8. And you want to check it because it could possibly be negative. If t was 1, 2 minus 7 is negative and it wouldn't exist, so I'd have no solution. But here it turns out t is 8, so we're okay. What would you guys do for the next one? The very first thing you would do is divide by 8. We do not like having anything in front of the log. Get rid of it. Divide by 8. So that would leave us log base 4 of w plus 6 equals 3. What would that be? Yeah, 24 over 8. simplifies it pretty quick. Take 4 to the power of both sides. Cancels the most complicated thing on this side. And then 4 to the third power. 64. Subtract 6 from both sides. We get W equals 58. Plugging that in, checking it, perfectly fine to do. You could also plug in log of 58 plus 6 divided by log of 4 times 8, and hopefully your answer would be 24, right? If you evaluate that left-hand side, you would get 24. Okay, see that? So it almost it's the same concept as what we did with exponentials, but the inverse of it, right? We want to get rid of the log instead of get rid of the exponent. Numbers are numbers, so don't get, 2.6 to a power to 2.6 is going to be a number. So how would I solve for W in the second one here? Yeah, right. I want to get rid of log, so I can take 10 to both sides. Doing it on the left-hand side simplifies that to W plus 47 equals 10 to the 2.6. So if I want to solve for W, I subtract 47 from both sides and get 10 to the 2.6 minus 47, which is 351.107. Both those answers are sufficient. If you put 10 to the 2.6 minus 47, you would get full credit there. If you plug that in your calculator, the nice thing about that is if you plug this number, add 47 to that, and take log, you should get 2.6. So you can see how now I have this decimal. I can add 47 and then take log of that number, and I get 2.6. That shows you the left-hand side equals the right-hand side. T, what would T be? Not quite.
Oh, wait, no, never mind.
So go ahead and look through the calculation. Go through the same process and try to find T. Good. Yeah. So I need to get rid of the log here. I have T minus 18 equals 10 to the 1.4. T would be 10 to the 1.4 plus 18, which would be 43.11 or 0.12 if I round. Check, is it possible? Yes. If I plug in log of 43.12 minus 18, I get about 1.4. Where it gets a little more, there's more steps involved when you have more than one log, right? I need to isolate the log by itself. So I need to get all the terms that have log on one side. Unless it's possible to get log base 2 plus log base 2, or log base 2 equals log base 2. If you can get it in that form, then you can just drop the log base 2's and set the parentheses equal to 0. What makes this one a little more difficult is I just have this 3.
Okay, so you can't just like drop the log.
You can't drop the logs. You have to get the logs by itself.
So can you divide it by 3?
You can't divide because that's the inverse of multiplication. Here I'm really adding 3 to both, or I'm adding 3 to this side.
Oh, okay.
Right? And I could subtract 3 from both sides, but then I would just end up with a 3 on the other side. So if I wrote this log base 2 of x plus log base 2 of x minus 2 equals 3, right? If I just move this to this side, what could I do to the left-hand side to make it one log? Yeah, so what is log base 2 of x plus log base 2 of x minus 2? How would I combine them? Good, right? So I could use the properties of log and say, write it as one expression, and that would be log of x times x minus 2. You guys remember properties of logs? When I add two logs, I multiply their insides to get it into one log expression. Yeah. And I can combine them inside together, so I could have log base 2 of x squared minus 2x equals 3. Now, how can I get rid of log base 2? Exponent, right? I take 2 to both sides. And that would give me x squared minus 2x equals 8. So now I have a quadratic. So when does x squared minus 2x minus 8 equals 0? X equals 4 or x equals minus 2, right?
Can't be negative.
It can't be, it can't be the minus 2, right? Because I'm taking log base 2 of x. So that's an extraneous solution. If I plug in minus 2, I have a problem. Because minus 2 for log base 2 of minus 2 doesn't exist. And log base 2 of 0 doesn't exist, right? So I would take out that solution and say x can only equal 4. Right? Here's where I kind of change my rule, putting x to the left-hand side. It's when it's more convenient. I like to deal with multiplication a lot more than I like to deal with division. So if I have negatives in front of my logs, I usually like to move them where I don't have negatives in front of it. So on the next example, I would probably want to move all the logs to the right-hand side just so I can avoid negatives. And negatives and logs change into division. I don't like to do more complicated stuff. However, mathematically, you can deal with it as long as you don't do anything illegal. Right? So if I move this term to this side, I end up with 2 equals log base 7 of x minus 48 plus log base 7 of x. Same approach. I want to combine it to one single log term. So I have 2 equals log base 7 of x minus 48 times x. And I use the multiplication because I'm adding 2 logs. So this would give me using the same technique, how would I get rid of log base 7? Yeah, take both sides as exponents of 7. So I have 49 equals x times x minus 48, which gives me 49 equals x squared minus 48x, which would then be 0 equals x squared minus 48x minus 49. Factoring that as x minus 49 and x minus 1. Sorry, x plus 1. Right?
Negatives already.
So then this would equal x equals 49 or x equals minus 1. Are both of those possible? I come up to my original 49 minus 48 will work because that's positive, and minus 1 will not work, right? So my only solution is x equals 49. It's possible to have no solutions. LN's the same technique, except your base is E instead of 10 or 7 or 2 or whatnot. But you want to end up doing the same thing. Could I combine one of these sides to get ln by itself on both sides? You can actually combine them all to one side and have equal 0. It's the same. You're going to get the same solution doing that. But if I only worked on the right-hand side, what would I need to write ln of x plus 6 minus ln of x? How does that relate to a single ln term? What would I have on top? And do I multiply or divide? Divide by x, right? So now I have the same ln on both sides. So if I took e to this side and e to this side, that would give me x minus 4 equals x plus 6 over x. Now I just solve for x. So multiply both sides by x. I end up with x squared minus 4x equals x plus 6. X squared, subtract x from both sides. Subtract 6 from both sides. I end up with a quadratic x squared minus 5x minus 6 equals 0. Factor it. I end up with x equals 6 or x equals minus 1. Can x be minus 1? No, because I can't take ln of minus 1. Can x be 6? Works here, and works here. So 6 is my solution. So you guys see how that worked out there? The next example, it actually turns out to get no solution. It turns out both my possible solutions aren't in the domain of the ln function. So what would I do to the next example to get ln on the left-hand side by itself or in one term? X minus 8, is that in the denominator or the numerator? Numerator, right? Because it's being added. So when I add two separate log terms, when I want to smush it to 1, I really multiply the insides. Here I have x squared minus 8x equals x minus 20. It would be x squared minus 9x minus 20 equals 0.
How did you
Question?
get minus 20?
Oh, sorry, plus 20. Thank you.
Okay.
Yeah, add 20 to both sides. Get plus 20. So five and 4. X minus 5, x minus 4. So x would be 5 or 4. Now if I check that, if I plug 5 minus 20, that's negative. And 4 minus 20 is negative. So neither work, so no solution. It's not possible. The left-hand side will never equal the right-hand side. It would possibly equal it at 5 and 4, but the domain doesn't allow it to be 5 and 4, right? So it is important in this logarithmic equations to plug it back in your answers to see if it's even possible.
But rest assured, it's negative.
If it is negative inside the parentheses, it doesn't work. It's possible your answer could still be negative. If I had ln of x plus 5, right? And if x equals -1, that still works.
Oh, yeah, okay,
Yeah, so yeah, if it has ln of x plus 5 plus ln of x, and x would equal -1, that would not work because it works in this one, but it doesn't work in this one. So you have to check every term. And then the last part of this is just the application. So before we talked about if I invest money for X amount of years, how much money am I going to have, right? Being able to solve exponential and logarithmic equation now tells me how many years do I need to invest it to double my money, right? So this example is saying using this formula, and it tells you the interest rate is 4.5%, and I have $8,000. So the model here would be A equals $8,000, 1 plus 0.045 divided by, it's compounded, does it tell us? Just N over N times T. Does it say compounded number of times compounded per year?
Right there. The one-
Okay, so the N becomes 1, right? No, it just, does it tell us N? Oh, monthly. N is 12. So this would be my model, right? If I say you invest it for 5 years, you can plug T is to be 5, and you can find me how much money am I going to have in 5 years? How much money am I going to have in 6 years, 7 years, 8 years, so forth, right? The use of exponential or logarithmic equation now tells me, what if I want to solve for how many years I need to double my money? I put $8,000 in, right? How long will it turn to double my money? Well, if I want to double it, I have 1,600, right? Ooh, 16,000 equals 8,000, 1 plus whatever this number is, 0.045 divided by 12 to the 12th t. So now my whole goal is to solve for t, right? So this is an exponential function. The first thing I want to do is get my exponent by itself, right?
In that
So-
case, are you looking for just a whole number, or are you looking for?
It's a decimal, right? So if I divide both sides by 8, I get 2, which makes sense because I want to double my money. 1 point, did I do this calculation? What is 1 plus 0.045 over 12 to the 12t? What would I do to get rid of that 1 plus 0.045 over 12? It's an exponent. So I'm going to take ln of both sides. That's one way to do it. Right. What is 1 plus 0.045 divided by 12?
Like, what is that?
What number is it? 1.00375. Right. 12t. If I want to get this by itself, I can take natural log of both sides. ln of 2 equals 12t times ln of whatever this number is, which is a number in your calculator, 0.00375. Now, how would I get t by itself? Divide by 12 times ln of this number, and I get t equals ln of 2 divided by 12 times ln of 1.00375. Again, for this problem, that's the exact answer, but that doesn't tell me how many years. So if I plug that in my calculator, what do I get? I should get 15.4 years. So that's telling me if I have $8,000 now, maybe I do it when my child is born, and I put it in a bank that has a certain interest rate that compounds it monthly for 15 years, if I do it for 15 years, my money will double, right? So I can know how much my child will have to buy a car when he turns 16, right? So if I want him to have $20,000, I need to recalculate it because I did 8,000. If I want him to have $16,000, I need to invest $8,000 when he's born or she's born to be able to buy this car. And hopefully inflation doesn't go up at the same rate, because then it's like having $8,000 and you're back at square one. All right, we'll finish the last question in this section, and then I'll give you guys your review on Wednesday.